CogNetCare is pioneering the future of cognitive health by using advanced 5G technology to improve early detection and continuous monitoring of cognitive impairments. This project integrates two technologies, Brain on Track and Neuron Stride. Brain on Track is a medically certified digital solution designed for remote cognitive screening. It uses interactive serious games to monitor cognitive functions and enable the early detection of cognitive decline. This tool allows people to be monitored comfortably from home, ensuring regular follow-up without the need for clinical visits. Neuron Stride focuses on remote gait analysis. By remotely tracking walking speed and fine motor control, it identifies subtle changes in mobility that may be linked to cognitive deterioration. It offers a non-invasive and objective way to assess motor function in daily life. By leveraging the power of high-speed, low-latency 5G networks, CogNetCare is paving the way for the future of cognitive health through 5G technology.
The Touristic project, developed within the Imagine-B5G initiative under the 6G SNS Horizon Europe program, pioneers the next generation of AI-driven immersive tourism experiences. Designed and implemented by Nomad River with the support of Ubiware, Capgemini, and the Instituto de Telecomunicações, University of Aveiro, Touristic combines advanced edge computing, AI inference, and extended reality technologies to elevate smart tourism and enhance local discovery. The project builds upon the slow.travel framework, connecting users, IoT sensors, and AI agents across edge and cloud infrastructures. Today, most travelers rely on manual web searches, moving between websites, maps, and social media to plan their experiences. This process is fragmented, time-consuming, and often disconnected from the traveler's real-time context. Touristic transforms this process by connecting users directly to intelligent, localized agents that understand their preferences and environment. Instead of searching the web, travelers can simply ask the system through natural chat, voice, or XR interfaces and instantly receive personalized, context-aware recommendations powered by AI and edge computing. This makes travel discovery seamless, immersive, and sustainable. At its core, Touristic connects distributed AI agents that collaborate in real time. Clients automatically discover and select the best available agent based on proximity and capabilities. They render and cache WebXR and AI-based content dynamically, ensuring fast and localized responses. The system supports multiple testing modes, streaming, non-streaming, and manual agent selection, and can be deployed either as a progressive web app or compiled to mobile operating systems. Its architecture includes local and central nodes, equipped with AI models, content retrieval services, and monitoring layers for caching and performance. Edge and cloud inference nodes enable scalable computation across the tourism data ecosystem. Multiple experimental trials validated the platform's integration and performance. The core platform integration confirmed seamless connection between the slow.travel framework and the 5G edge infrastructure. The end-to-end experiment demonstrated full AI and VR service integration, measuring KPIs such as latency and user experience. The on-street node and IoT integration connected environmental sensors to gather real-time data, enabling dynamic recommendations and context-aware experiences. Initial results showed strong energy efficiency, accurate positioning, and robust AI inference performance. GPU-based agents improved accuracy and response time, even with quantized models, while IoT data enhanced AI-driven content delivery. Through the slow.travel chat interface, users interact naturally with intelligent agents that provide real-time, location-aware suggestions and immersive XR content. Whether asking for nearby attractions or requesting a virtual tour, the system delivers instant, meaningful responses powered by edge-to-cloud AI collaboration. Touristic is advancing towards technology readiness level 8, with large-scale demonstrations done both at EUCNC 2025 and Avero Tech Week. The platform operates across two edge nodes, one edge cloud and one central node, integrating AI inference, content retrieval, and IoT data fusion in real time. By combining AI, XR, and IoT in a unified, intelligent framework, Ntour XP lays the foundation for the next generation of personalized, sustainable, and connected travel experiences. Wherever you go, go slow.
Hello, I'm Daniel Caraz from RedSync. We've been part of the second open call of the Imagine-B5G project, and we have been working closely with Altis Labs in Portugal to bring advanced 5G solutions to emergency healthcare scenarios. Welcome to the final video of Project Critical.
Project Critical is a vertical experiment focused on improving emergency medical response using Altis 5G standalone networks and mobile edge computing capabilities. We tested the Blue Eye connected paramedic platform, which allows paramedics to send real-time biometric data and live video from the field to remote hospital teams. The main goal is to reduce time to treatment and enable better clinical decision-making, right when it matters most. The project was achieved by RedSync, who developed the Blue Eye connected paramedic platform used in the trials, and Altis Labs, who provided the 5G infrastructure and test facility. RedSync provided the wearable video system, the biometric sensor integration, and the real-time dashboard for hospital specialists. Altis Labs hosted the trials in their 5G test facility in Aveiro, Portugal. They provided the 5G standalone network, mobile edge computing, and managed network slicing, enabling us to test the system under realistic operational conditions. Our objective is clear: prove that advanced 5G can support mission-critical healthcare, combining wearable sensors, video, and secure data handling in real time. We ran a full trial with stakeholders and 2 testing trials validating core features like network slicing, ultra-low latency, and secure, end-to-end encrypted transmissions. As a result, we reduced treatment delays, supported real-time clinical feedback, and demonstrated the platform's readiness for scale. Our system was integrated into the Altis Labs 5G SA network, using mobile edge computing and 2 dedicated network slicers, one for broadband high-definition video and another for ultra-reliable low-latency sensor data. We deployed our back-end components on the MEC and ensured GDPR-compliant data processing entirely within the EU. Thanks to this setup, we achieved technology readiness level 7. We demonstrated 2 real-world scenarios. First, a polytrauma emergency, where a paramedic streamed vitals and video to a remote trauma specialist. Second, a hospital-at-home use case, where the patient was stabilized and monitored remotely, without being transferred to a hospital. In both cases, our system worked in real time, supporting early intervention and continuous care. Here you have some video footage from our final demonstration with the stakeholders.
First feedback from the doctor on the other side, and when I get this feedback, the doctor will tell me to keep the sensors. For example, here you see, I'm pressing,
Feedback from Altis Labs, firefighters, and other observers was very positive. They praised the platform's stability, ease of use, and clinical value. End users confirmed that the system has the potential to transform how we deliver care in both urban and remote emergency settings. Also, they mentioned other use cases where it may be interesting, like cross-border cooperation as well as post-marathon care points. Participating in Imagine-B5G project gave us access to cutting-edge infrastructure, technical guidance, and a real facility to test under operational conditions. Thank you to the Imagine-B5G team, Altis Labs, and everyone involved. Project Critical has proven that 5G can support connected care when it's needed most.
Hello everyone, my name is Enrico Alberti. I'm from Nexus and I'm responsible for the extension of the monitoring platform in the OPTIMITER project, a project about monitoring the energy and resource consumption. Basically, I have working closely with the Southeast Technology University in Aveiro, so in the Portuguese Facility. So the idea of the project is to realize this monitoring platform for the retrieval, the unification and the storage, and the distribution of the data. So basically it has been extended at this platform by adding multiple plugins in the data collection adaptation layer in order to retrieve data from several data sources, so the physical nodes, the container, the VMs for the resource consumption as well as the energy consumption or of the pods. And basically the data were stored in the Kafka and the eFlux such that later on consumers can retrieve the data using the client libraries or the REST APIs. So basically the integration in the facility was done thanks to support to CHHA University, Technology University. So they have this data center. We use this part of the data center in which there was many servers that has been installed in the PDUs. In which let's say the PDUs were installed inside the rack with a duplication, so the placement duplicated as left and as right. And inside each server we installed all these tools, so the Kubernetes, the Proxmox, the OpenStack as well as the Scaphandra or the Kepler. About the demo, let's say it was shown that it was possible to configure a monitoring job to start a collection from these data sources, so Kubernetes is shown in the picture, and it was possible to choose the collection interval to retrieve, which node or which pods, and as well as the cluster of reference to create or to delete this kind of job. And then later on it was possible to monitor the information thanks to the dashboard available in the Influx tool. For instance, in the picture it was possible to show the active power consumption from the rack number 16 that was containing several servers. Now we can see here the top two, the Hobbits and Nintendo server, were consuming respectively 300 watts and 150 watts. So for the NeoNet point of view, instead, the idea was to consume actually the information provided by OPTIMITER collection in order to design, train and deploy AI models. So basically the focus on the energy consumption, both on the rack, bare metal and virtualized infrastructure, focusing on Kubernetes. So the idea was to migrate the running services the services running in the data center in order to optimize the energy consumption. So there was here on the left we can see the flow. They were collecting the data and they were processing them in order to train the algorithm. So basically you can see here the picture and the architecture of their experiment. They have two clusters with the high availability, with the free master and free worker. So they basically, let's say, was using the physical energy from the Scaphandra and the Eaton PDU and the virtual energy from the Scaphandra and the Kepler. And the idea was that they use KS to perform several tests on the Kubernetes cluster in order to load or to stress the spike and to smoke. And later on they were using the AI pipeline in order to test and, let's say, develop these AI algorithms, and they were using the NeoNet scaler in order to, let's say, scale up and down the instances in order to enhance the system efficiency. So, and basically I hope you enjoyed the video and it was clear the objective of the project. So that is basically to retrieve energy and computational resource consumption both on physical and virtual assets, because at the end of the day only what is measurable could be improved. Thank you for the vision.
As leaders of the Connected Home for Healthy Aging project and its two use cases, we are pleased to welcome you to this brief presentation of our project. We are affiliated with University of Aveiro and IETA Research Unit. IETA main mission is to develop intelligent systems for human assistance. CHHA derives from a long-term project in collaboration with industry and a rehabilitation center, striving to support healthier aging in home environments, providing assistance with tasks, prevention, rehabilitation, and health monitoring. Main objectives selected for the project were prototyping and evaluation of new solutions for healthier aging supported by For Smart Homes, explore and assess the potential of B5G technologies to support those new solutions, focusing in two use cases that have been identified previously as relevant. First use case refers to a virtual gymnasium, motivating users to be more active by allowing them to do exercises without leaving their homes.
Olá, eu sou o Jim, o seu assistente de treino virtual. Bem-vindo ao seu ginásio em casa.
Olá, Jim. Vamos começar.
Vamos começar? Fantástico.
Second use case refers to continued activity monitoring and resorts to radar technology. Both use cases fit perfectly into the e-health vertical of Imagine-B5G. Both have potential to promote healthier lifestyles, contributing to preventive medicine. Tests were performed at the facility to measure relevant KPIs, such transmission and processing times. The prototypes were deployed at IT Aveiro facility and demonstrated in September 2025. Participants were able to try the systems. For radar-based activity monitoring, they also used the developed web application to access aggregated information. A group of users participated in the evaluation by carrying out tasks and sharing their feedback through a questionnaire. Evaluation contemplated parameters related to network performance, such as response velocity, quality of extracted information, as well as interaction. Users responded positively to the quality of the extracted skeleton, as well as the system's intuitiveness and fluidity. Users responded positively to the radar-based monitoring system, highlighting its unobtrusiveness, privacy-preserving nature, and practical value. Imagine-B5G main contributions were: make possible cloud-based processing for both proof-of-concept services, offloading computation from homes, and providing security mechanisms essential for e-health. The two proof-of-concept developed by the project, virtual gym and radar-based monitoring, showcase the power of low-latency, secure, cloud-integrated networks to deliver e-health solutions for home environments. Our work demonstrates the transformative potential of advanced networking technologies in reshaping digital health and unlocking new capabilities for B5G.